Welcome, Hornets. Thank you for joining me today. Today we're going to be taking a look at a warm-up that is involving equations of tangent lines and finding derivatives of inverses and trying to use our calculators as well as not using our calculators. So we're going to start off by taking a look at number 1. If we are given f of x equals x squared plus 4x minus 5, and we are trying to find f of 2, f prime of 2, and the equation, the tangent line, 2f at 2 in point-slope form, the first thing I want to do is I want to start off by just trying to figure out what is my derivative. So if I know f of x is equal to x squared plus 4x minus 5, then f prime of x is going to end up being 2x plus 4. This will allow me to now plug in the 2 that I am looking at. So if I plug in 2 into the f of x, I'm going to find that I get a 7. And therefore, the first answer we're looking for is that f of 2 equals 7. Notice we have 8. 8 plus 4 is 12. 12 minus 5 is 7. Then we're going to find f prime of 2. It means I'm looking for my derivative. That's the slope of the tangent line. I'm going to plug in the 2, and I get 2 times 2 is 4, plus 4 makes 8. Now, once I have these two values, I can find the equation of the tangent line as f of x minus my y value 7 is equal to the slope of the tangent line times x minus 2. And there are the 3 answers that we are looking for in this warm-up so far for question 1. We're now going to go ahead and take a look at number 2. Now, number 2 is saying if we have f and g are inverses, and we're trying to find f prime of 3, the first thing I want to do is figure out, well, what is f of what makes 3? So I'm going to look down at my information. You notice they give me a lot more than I need. So we have to find the specific value where f of 2 is equal to 3. And now I'm going to be looking for my derivative at 2. I'm going to find f prime of 2, and you'll notice I get a 6 here. And now I can answer the question, because we know the relationship. G prime of 3 has to equal 1 over f prime at 2. Notice the point 2, 3 right there. We're now going to substitute f prime of 2 with its value, and we get 1/6. So we now know that f prime of 3 is 1/6. Now granted, I could at this point find the equation of the tangent line to g at 3. After all, I know that g prime of 3 is 1/6, and I also know that g of 3 is 2. So I could follow the same process I did in number 1. Number 3, we're now being asked to use a calculator. So the first thing I want to do is I want to try to figure out how to put this into my calculator. Let's just go ahead and clear a few things out. Go to my home screen, and I'm going to clear things out there as well. So y equals, and I'm now going to put in e to the power of pi minus x squared, move my arrow, and put in the sign of 4x minus 1. I'm looking for when is the g prime, so I'm thinking about it in terms of f of what is equal to 10, and then once I have this value, I will be able to find my inverse, g prime of 10, by using 1 over f prime of whatever value I'm getting. Okay, so that's my plan. So I'm going to start off using my calculator. I'm going to put in 10. The interval they give me is from 0 to 1/2. So Windows, 0 to 1/2, so 0.5. And I'm going to hit a zoom fit and just see what happens. It may give me a terrible graph. Alrighty, so notice, didn't help. Let's try zoom fit. There we go. Now I can see what I want. And There's the value. Now notice this portion of the function is 1 to 1, which is why I have a restricted domain. I know that this value will work. So let's find what is that value. This is an intersection. So second trace, find the intersection 5 between the two functions. Now I'm going to want that value right there. Now keep in mind, I could immediately work with the derivative. Now go to my home screen, hit math 8, x for the original function alpha trace y1 at x. Now notice, once I put in the x, it's going to give me the x that's on the graph that we were just looking at. And if I hit enter, I get 61.74692176. Now I want that entire value. But what I want, if you recall, is the reciprocal. Because what I'm looking at is the b value for the inverse point. So we're going to take this again, and I'm going to go 1 divided by my answer in order to find the derivative. That is the derivative that I'm looking for. And g prime of 10 has to be approximately 0.016, and I'm just going to go to 4 decimal places for the sake of argument. Okay? Now, I also want everybody to be able to use their calculator and store values. That was what I was trying to show everybody on Friday. So if I hit X right now, the X that was on the graph is going to be the X that I will see coming up. Enter. Notice I can now do store. So I'm going to hit store. That's this button right above the on button, STO, and it'll now say the answer where. And we're going to use one of these green letters. I personally like alpha math, which is A, and if I hit enter, I now have it stored. So you'll notice I can now repeat the same process. Math 8, x, alpha trace y equals, at alpha A. Notice it gives me the same value, 61.74692176, and I want that large value. I can then take 1 divided by the answer. The answer is second negative, so second negative gives me ANS. When I hit enter now, I get the same derivative. Okay, so notice this is using your calculator to find the inverse of a function that we do not yet know. All right, let's go ahead and take a look at the last and final question. The last and final question says that we are given the function f of x equals x to the 5th plus 3x minus 2, and it passes through the point 1, 2. Let f inverse denote the inverse of f. Without using a calculator, find the derivative of the inverse at 2. Alrighty, so what do we know? F prime has to be 5x to the 4th plus 3. And f prime of the corresponding value, which would be 1, right, at the point 1, is giving me 8. Since we know that the inverse derivative at 2, the b value of f of x, is the reciprocal of f prime at its a value, or the b value to the inverse, I can now substitute, and my answer is 1/8. Okay, now you'll notice I've done everything I need. If I wanted, I could find the equation of the tangent line to the inverse at x equals 2, in which case I would be looking at the inverse of x minus my y value, 1. Notice the points are flipping, they're switching, right? And as a result, instead of looking at 1, 2, the inverse is looking at 2, 1. So I put my 1 for my y value, I have 1/8 is the slope of the tangent line, and then I have x minus 2. This then is the equation of the tangent line to the derivative of the inverse of the original function f at the point 1, 2, but for the inverse function at x equals 2, where the y corresponding value is 1, and the slope is the reciprocal of the derivative of f originally, which was 8 for 1/8. And then I just put it together. That was our warm-up for today. I hope that it helps. Please feel free to click like if you found it useful, and if you have suggestions for how I might improve, please always give me criticism. I find it useful, and I'll try my best to improve as I go. Thank you very much, Hornets. Please be safe and take care. Be kind to each other and yourselves. The world is hard enough without making it more difficult. Cheers.